In this video, we are going to learn the angle and cyclic properties of a circle. We will learn some theorems based on the angle properties of circle and then apply them in the questions. Now, Theorem 1 says that the angle subtended by an arc of a circle at the center is double the angle subtended by it at any point on the remaining part of the circle. So let's have a look at this arc. Arc AB subtends means makes angle AOB at the center. If you look at this arc AB, it makes angle AOB at the center, right? And it also makes or subtends angle ACB at the circumference, right? So arc AB makes two angles, one at the center and another at the circumference. Now the theorem says that angle subtended by an arc at the center is double. Then what? Then the angle subtended by the same arc at the circumference, right? So what does that mean? It means that if this angle is x, then this angle will be 2x, right? That's what the theorem says. So we can say that angle AOB is 2 times angle ACB. So let's repeat the theorem again. Angle subtended by an arc at the center is always double the angle subtended by it at any other part of the circumference. Now you may say that, is it necessary that it has to make it just below this? No, it can be here also. It can be anywhere, right? So this angle will also be x, right? So we have taken the minor arc. If you look at this arc, this is the minor arc and this is major arc AB, right? So let's see what happens when the major arc, that's AB is the major arc now, which angle it subtends at the center? Reflex angle AOB, that means this angle, right? Now this angle will be double then the angle subtended by this arc at the center. Which angle this major arc subtends at the center? This angle, right? So if this angle is x, this will be 2x, right? Fine. So that is our theorem 1. Let's go to the theorem 2. Now, if you look at theorem 1, here, this will help us to understand theorem 2 better. You saw that arc AB subtended this angle at the circumference. Arc AB also subtended this angle at the circumference. Arc AB may subtend this angle at the circumference. This will also be x. This is x. This is x. Does that mean that same arc subtending different angles at the circumference are equal? Right? We are going to make use of this here. Now see, our theorem 2 says that angles in the same segment means arc. You can call it as an arc also. Angles in the same segment of a circle are equal, right? So if arc AB subtends angle ADB at the circumference and angle ACB at the circumference, both of these angles will be same. So if this is x, this will also be x, right? Same holds true for the major arc also. So major arc subtends this angle at the circumference as well as this angle at the circumference. So both angles will be same, right? So let's repeat the theorem. Angles in the same segment of a circle are equal, right? So these are the two theorems. We'll do some more theorems now. Our theorem 3 is saying that the angle in a semicircle is a right angle, right? Now consider a circle. You can see that if this is O, that means this is the center of the circle. You can see that AB is the diameter of the circle, and then this part becomes the semicircle and this part also becomes the semicircle. Now if you have an angle in the semicircle, its measure is always 90 degree, right? Now we have done theorem 1 here. What does it say? It says that angle subtended by an arc at the center is double the angle subtended by it at this angle is double the angle subtended by it at any other part of the circumference. We are going to apply the same thing here actually. Now see, what is arc? This is arc AB. Which angle is it subtending at the center? 180, right? Now the same arc is subtending angle ACB at the circumference. So obviously it has to be the half of it, right? That's how we remember that angle in a semicircle is a right angle. Theorem 4. Now this theorem is based upon the cyclic quadrilateral, right? What is a cyclic quadrilateral? A quadrilateral whose endpoints lie on the circumference of a circle are known as cyclic quadrilaterals. All the quadrilaterals whose endpoints lie on the circumference of a circle, we call those quadrilaterals as cyclic quadrilaterals. Now, what is the property of this cyclic quadrilateral? Opposite angles of a cyclic quadrilateral are supplementary. That means if this angle is x, this is y, then angle x plus y is equal to 180, right? That's what it means, that opposite angles of a cyclic quadrilateral are 180 degree. So that holds true for these two also. If this entire angle is P and if this entire angle is Q, then we can say that P plus Q is equal to 180 degree. That's what our theorem 4 says. The opposite angles of a quadrilateral inscribed in a circle are supplementary. So what is the name of this quadrilateral which is inscribed inside the circle? Is cyclic quadrilateral. We call this quadrilateral as cyclic quadrilateral. And what is its property? That its opposite angles are supplementary, which means that sum of those angles are 180. Fine. One more property of this cyclic quadrilateral is that if we have a cyclic quadrilateral, say A, B, C, D, why is this a cyclic quadrilateral? Because its endpoints lie on the circumference of a circle. Then its exterior angle, you see this exterior angle, is always equal to its interior opposite angle, right? So if this angle is x, this will also be x, right? So let's extend this line. Now this becomes the exterior angle also of this cyclic quadrilateral. So if this is y, this will be equal to its interior opposite angle. That means this. Right? So what is the theorem 5 saying? The exterior angle of a cyclic quadrilateral is equal to its interior opposite angle. Right? Now we are going to use these theorems or apply these theorems in the questions in the next videos.